Vertical mobility, or the ability to move in the vertical domain, is a core requirement of our vertical rescue operators. At the time of assessment, we require new vertical rescue operators to be able to demonstrate that they can correctly apply the techniques in order to move safely on rope. It's important to recognise that this is the starting point of a successful vertical rescue operator and not the goal. As vertical rescue operators, we need to aspire to be truly proficient and efficient at moving in 3 dimensions. Search and rescue operations that vertical rescue operators are often involved in require a considerable amount of mental capacity to undertake the task at hand. Any mental capacity that we as operators require just in order to move about reduces the amount of capacity remaining for us to complete the job at hand, making it very important that moving in 3 dimensions is as natural to us as walking or driving a car. We want these skills to become second nature. In considering how to approach the topic of vertical mobility, I've decided to deliver it as a set of short videos. The first video, or this one, will provide a review of the equipment that we use and some basic principles of operation. The second video will provide a refresher for us on the basic techniques of moving in the vertical domain, and subsequent videos will look individually at areas where many operators can improve their efficiency or effectiveness at moving on rope. So, the introduction. As I said, this is a review of the equipment that we use and how we use it, as well as some tips on how to set the equipment up to be just right for us. To start with, I have my personal tether, or cow's tail. This is a length of dynamic rope. It's important that this is dynamic rope because in some operations there's the possibility that either we or our casualty will fall and have that fall arrested by this rope. Dynamic rope has significantly greater stretch than the static rope that we typically construct systems with. My personal tether is a Petzl Progress Adjust. It's not important whether your tether is a Progress Adjust or not. I really like this tether because it's very easy for me to adjust. You can see the length at the moment. If I pull the tail, it shortens and immediately locks under load. Similarly, I can easily lengthen it and it remains at that length. Secondly, I have my fall arrest device. Now I've placed my tether back on my harness. I'm not going to use that for the majority of my vertical mobility exercises, but for some techniques it becomes critical. Fall arrest device, however, is the first item that I place on my rope and the last item that I take off my rope. In the SES we use the Petzl ASAP. We typically issue the ASAP lock, which is slightly different from this device in that we don't need to remove the carabiner from the ASAP lock to take it on and off the rope. If using an ASAP rather than an ASAP lock, it's important that our carabiner captures the rope. So our fall arrest device, as we can see, there are 2 components. There's the ASAP itself. Now this is a device that's designed to run freely up and down a rope. If it moves at 2 meters per second or greater, i.e. if you fall or slide, it will lock to arrest your fall. And this is where the second part of the fall arrest system comes into play. We have a shock absorber here. This shock absorber is designed so that it will deploy at less than 6 kilonewtons of force. So if we were to have a severe enough fall that capturing that fall would result in injury to our body, the shock absorber would elongate to reduce the impact on our body. 2 components in one, always used together, and our fall arrest device needs to be attached to an attachment point on our harness that is rated for fall arrest. On most harnesses, that's the sternal attachment point, or the attachment point at the chest. It's important to remember that the ventral or waist attachment point on a harness is almost never rated for fall arrest. Similarly, our lateral or side attachment points are not rated for fall arrest. So I have my fall arrest device, as I said, first thing on our system and the last thing off when we're done. Next I have my descending device. As you know, in the SES we use the Petzl ID as a descender. Obviously I'm going to be starting by ascending the rope rather than descending the rope. But this is our device. As we can see, the device has a handle that can be moved into various positions. When not in use, we should try to have the handle closed completely in the position marked Store on the rear of the device. It's also important that when there is a rope through the device, we not try to close the handle completely into the Store position. If we do force the handle into that position, we risk damaging the cam, which provides the primary method of operation of the device. So with a rope attached through the device, if I want it to be locked, so I don't need to hold on to the tail and the handle, I close it to this position, which is marked lock in the rear of the device. With the handle open, marked as Belay Mode on the back of the device, I'm able to pull slack through the rope and slack will not come back in. This can be useful as a belay method if we're using a main and belay hauling system, for example. And finally, to release the device, we open it all the way. Being careful with the ID that it has an anti-panic function. If we open the device too far, it will lock itself, requiring us to close the handle, reopen it again to activate it. With all of our devices, before use, it's important to do a quick function check. You saw earlier when I was demonstrating the operation of the ASAP, I pulled it suddenly downwards to engage its locking mechanism. By doing that, I verified that it works correctly, that having been stored, it hasn't suffered some form of damage. Similarly, with my ID, it's important to ensure that it functions correctly. It's also important to ensure that we've reeved the rope through the device correctly. The easiest way of doing that is with the handle in belay mode, ensuring that we can pull slack through on the tail and that when we pull down, the device locks. The final pair of devices that we'll look at are our two ascenders, which we'll be using to ascend the rope. Firstly, I have a hand ascender. The basic operation of these devices is hopefully well understood. We have a thumb catch here that allows us to release a cam that contains teeth on it. The rope should sit between the wall of the device and the toothed cam, like so. We can slide it up, we cannot slide it down. That's easy. Important things to bear in mind with ascenders are if we want to use our ascenders to descend the rope, so descending the rope while remaining on our ascenders, we can absolutely do this, but it's very important for our own safety that we not use the thumb loop when doing so. Rather, we should operate the cam directly, either by, in the case of this ascender, it's got a little thumb hole there that we can use to open the cam, slide it down the rope, or if your device doesn't have that, you can put a finger into the top of the device and depress the cam directly. This is important because it ensures that we can't accidentally take the ascender off the rope and then potentially fall quite some distance. At the bottom of our ascender, I have a leg loop. Having leg loops that are the correct size for our body can make a huge difference in the efficiency as well as the energy that we need to use when climbing a rope. What's a good length for leg loops? Now, because we are all sized differently, there's no hard and fast rule, which is one thing that makes adjustable leg loops extremely valuable to invest in. But a good starting point for leg loop length is with a foot in the leg loop, the hand ascender should approximately be at the height of your sternum. So when training new operators in vertical mobility, this is where I tell them to start. Adjust their leg loops so that the hand ascender sits at their sternum, spend some time climbing rope with loops that size, and if necessary, adjust as you go. And you can get a much better feel for this once you're on rope. Having raised my hand ascender, and we'll be able to look at this in more detail in the next video, my leg loop should place my leg in close to a horizontal position. This provides a good balance between the amount of effort required to raise myself up for the next step and the amount of height gain I obtain from each step. It also makes it easy for me to put my foot underneath my centre of gravity, under my bum, which will keep me much more balanced, thus also requiring a lot less energy to ascend the rope. Alongside our leg loop, we have another cow's tail. This attaches our hand ascender directly to our harness. And this is important. If I was standing up in my leg loop and it were to fail, I would obviously fall. In this situation, I would fall a couple of inches before being caught on this dynamic rope. It's important that whenever we're using a hand ascender, that hand ascender is attached to our harness using some form of attachment. Our second ascender is our chest ascender, and we're all familiar with the full body harnesses that we use to, for example, work on roofs. These don't have an integrated chest ascender. Vertical rescue harnesses or work positioning harnesses do have an integrated chest ascender. These operate in exactly the same way as the hand ascender. They're just a little bit smaller. If your full body harness does not have an integrated chest ascender, it's entirely appropriate to affix a chest ascender in place in essentially any way you like. It's important to ensure that the bottom of the chest ascender is secured with some form of life-bearing attachment to your harness. So it's that attachment between your harness and the bottom of the chest ascender that needs to be absolutely secure. At the top, you can see here I've used a simple length of 12mm tube tape to keep the chest ascender in an upright position. So I finally attach the rope to my chest ascender and I'm ready to ascend the rope. The final point I want to mention is the location of my fall arrest device. You can see I have my arm underneath my fall arrest device, and that's where I want it. If something catastrophic were to happen to the line that I am climbing and I were to fall on my fall arrest device, I want that to be able to deploy without breaking my shoulder. That's it for today. Next time we'll look at actually climbing our rope.